Hello and welcome to The Sleepy Physicist. I'm so glad you're here. Whether you're settling into bed, curling up on the couch, or just trying to wind down after a long day, you've come to the right place. This is a quiet little corner of the internet where science gets soft-spoken and curiosity puts on pajamas. Tonight, we're diving into the most mysterious realm on our own planet, a place more alien than Mars, more unexplored than the surface of the moon, and more abundant with impossible life than any science fiction writer has ever dared to imagine. Right now, as you listen to my voice, there are creatures living in complete darkness, 7 miles beneath your feet, creatures that breathe poison, create their own light, and thrive in pressures that would crush a submarine like a tin can. They live in a world where water boils, yet somehow stays liquid, where single cells grow larger than dinner plates, and where the very chemistry of life operates by rules we're only beginning to understand. Now, I do hope this video isn't so fascinating that it keeps you awake. But hey, if it does, at least you'll be learning something extraordinary about the final frontier on Earth. A fair trade, I'd say, before we begin our gentle descent into the abyss. If you enjoy these slow science journeys and you'd like to help this sleepy little channel grow, I'd be ever so grateful if you tapped the like button, subscribed, or even just left a comment telling me where in the world you're watching from and what time it is in your corner of the night. Alright, take a deep breath, settle in. Let's begin our quiet voyage into the secret life of the deep sea. Picture this. You're standing at the edge of the ocean. On a calm evening, the surface stretches endlessly toward the horizon, gentle waves catching the last light of day. It's peaceful, almost meditative. But beneath that serene surface lies the most extraordinary secret. Our planet keeps the deep sea covers more than 95% of our world's living space, yet we've explored less than 5% of it. To put that in perspective, we know more about the surface of Mars than we do about the deepest parts of our own oceans. We've mapped every crater on the moon in exquisite detail, but the vast majority of our seafloor remains as mysterious as it was to our ancestors thousands of years ago. It's a humbling thought, isn't it, that the greatest frontier for discovery isn't light years away among the stars, but right here beneath the waves. The deep sea begins where sunlight ends roughly 650 feet below the surface. Beyond this point, no photon from our sun will ever penetrate. The darkness is absolute and permanent. It has been this way for billions of years. This is the midnight zone, and it extends down through layers upon layers of crushing pressure and bone-chilling cold until it reaches the deepest trenches on Earth. Places where the pressure is over 1,000 times greater than what we experience up here in our comfortable world of air and light. But here's what makes this darkness so extraordinary. It's not empty, it's not silent, and it's certainly not lifeless. In fact, the deep sea is teeming with more biodiversity than tropical rainforests. It's home to creatures so bizarre, so perfectly adapted to impossible conditions that they challenge everything. We thought we knew about the limits of life. Imagine, if you will, a world where the most common form of communication is light creatures that have never seen the sun create their own illumination in colours that would take your breath away, blue-green flashes that pulse like cosmic Morse code, red beams that cut through the darkness like underwater lasers, and bioluminescent displays, so intricate they rival the most elaborate fireworks show you've ever witnessed. This isn't science fiction. This is science fact. Roughly 76% of all creatures in the deep ocean can produce their own light making. Bioluminescence, arguably the most common form of communication on our planet, more widespread than human speech, more universal than birdsong, yet most of us will never witness. this alien light show happening in the depths below. The story of how we discovered this hidden world is almost as remarkable as the world itself. For most of human history, the deep ocean was a complete mystery. Ancient civilizations imagined it as the realm of sea monsters and angry gods. Early scientists believed it was a biological desert devoid of life. They called it the Azoic Zone. The lifeless zone, how wrong they were. It wasn't until 1877 that we got our first glimpse of deep sea life, when the British research vessel Challenger pulled up samples from the deepest parts of the Atlantic Ocean. What they found changed biology forever. Instead of empty mud and barren rock, their nets came up teeming with creatures unlike anything anyone had ever seen before. Jellyfish with bodies like living crystal fish, with telescoping jaws and needle-sharp teeth, crustaceans armoured like medieval knights, but transparent as glass and everywhere. They looked more life, more diversity, more impossible adaptations to a world that shouldn't be able to support life at all. Since then, our exploration has revealed wonders that seem to come from another planet entirely. There are fish that carry their own fishing lures, glowing appendages that dangle in front of their mouths, like biological neon signs, attracting prey in the darkness. There are creatures that look like they're made of liquid light, their bodies pulsing with waves of blue and green luminescence. There are animals that have never evolved eyes because in their world, sight is useless. Instead, they navigate by sensing the faintest electrical fields generated by the heartbeats of other creatures. They live in a world of bioelectricity where every living thing generates its own signature energy field. And then there are the giants in the deep sea where food is scarce and precious. Many creatures have evolved to grow to enormous sizes. There are single-celled organisms called xenophyophoraes that can grow larger than dinner plates. Imagine that a single cell, with no brain, no nervous system, no complex organs, yet somehow thriving in one of the harshest environments on Earth. The deep sea challenges our most basic assumptions about life. We used to think all life depended on the sun, that photosynthesis was the foundation of every ecosystem on Earth. But in the deepest parts of our oceans, scientists have discovered something revolutionary. Entire ecosystems powered not by sunlight, but by chemistry. These are the hydrothermal vents, underwater geysers that spew superheated mineral-rich water from deep within the Earth's crust. The water that emerges from these vents can reach temperatures of over 700 degrees Fahrenheit. Hot enough to melt lead, yet somehow life not only survives here, it thrives around these vents. Scientists have found some of the most extraordinary creatures on Earth. Giant tube worms that can grow 8 feet long, with no mouth, no stomach, and no digestive system. How do they survive? They formed a partnership with bacteria that live inside their bodies. The bacteria feed on the chemicals from the vents, and in return provide all the nutrition the worms need. It's a relationship so intimate, so perfectly evolved, that neither partner can survive without the other. These hydrothermal vent ecosystems are completely self-sufficient. They need no energy from the sun, no connection to the surface world. They exist in a realm of perpetual night sustained entirely by the chemical energy that bubbles up from deep within our planet, and some scientists believe these vents might be where life itself first began. Billions of years ago, the conditions around hydrothermal vents are remarkably similar to what early Earth might have been like, a hot toxic chemical soup, where the first organic molecules could have formed and begun their slow evolution toward life as we know it. If this is true, then the deep sea isn't just home to alien life. It might be the birthplace of all life on Earth, including us. But perhaps the most mind-bending aspect of deep sea life is how these creatures have solved problems that seem impossible. The crushing pressure alone should make complex life impossible at the deepest parts of the ocean. The pressure is equivalent to having 50 jumbo jets stacked on top of every square inch of your body. Yet somehow, deep-sea creatures not only survive this pressure, they require it. Their bodies are so perfectly adapted to high-pressure environments that if you bring them to the surface, they literally fall apart. Their proteins unfold, their cellular structures collapse, and their bodies expand like balloons. How do they do it? How do they maintain the delicate chemistry of life under conditions that would instantly kill any surface creature? The answer lies in one of the most elegant molecular adaptations ever discovered. Deep sea fish produce a chemical called T-myo-trimethylamine oxide that acts like a molecular chaperone, protecting their proteins from the crushing pressure. The deeper a fish lives, the more T-myo it produces. It's a perfect biological barometer. Scientists can actually tell how deep a fish normally lives just by measuring the concentration of T-myo in its tissues. It's as if each creature carries a chemical signature of the depth it calls home. This adaptation is so precise, so finely tuned, that it reveals something profound about evolution. Life doesn't just adapt to extreme conditions, it embraces them. It finds ways to turn impossible challenges into evolutionary advantages. The crushing pressure that would destroy surface life becomes a protective barrier that keeps deep-sea ecosystems isolated and unique. And this is just the beginning of our journey into the deep sea. In the next part of our exploration, we'll venture even deeper into the abyss, where we'll discover how creatures create living light in the darkness, how they've evolved to see colours that don't exist anywhere else on Earth, and how some have learned to hunt with weapons made of pure sound. We'll explore the vast abyssal plains that cover more than 70% of our planet's surface, yet remain more mysterious than the far side of the moon. We'll meet the extremophiles, creatures that thrive in conditions so harsh they're helping scientists understand how life might exist on other worlds, and we'll uncover the latest discoveries that are rewriting our understanding of what's possible in the deep sea, including the mind-blowing revelation that some parts of the deep ocean are actually producing oxygen in complete darkness, a discovery that could revolutionize our understanding of life itself. The deep sea is calling to us whispering secrets that have been hidden in darkness for billions of years, and we're only just beginning to listen. So stay with me as we continue our descent into the most alien world on our own planet, where every discovery challenges what we thought we knew about life, the universe and our place in it. Next time we'll explore, can we comprehend the mind-bending size of the universe? But for now, let your thoughts drift like marine snow through the dark waters of the deep, carrying with them the wonder of a world that exists in perpetual night, yet blazes with the light of life itself. But to truly understand the alien nature of the deep sea, we need to talk about something that might sound impossible. Imagine creatures that can see colours that simply don't exist anywhere else on Earth. Colours that have no names because no human eye has ever witnessed them. In the deepest parts of our oceans, evolution has crafted visual systems so specialised, so perfectly adapted to their dark world, that they perceive reality in ways we can barely comprehend. Most deep-sea creatures that have retained their vision see primarily in blue and green wavelengths. This makes perfect sense when you consider that these shorter wavelengths can travel furthest through water. But here's where it gets fascinating. Some deep-sea predators have evolved the ability to produce and detect red light, giving them an invisible advantage in the eternal darkness. They're essentially using infrared night vision, hunting with a spectrum of light that their prey cannot even perceive. Picture a deep-sea anglerfish, its modified dorsal fin transformed into a living fishing rod topped with a glowing lure. But this isn't just any light. The bioluminescent bacteria living in that lure can produce light so precisely tuned to attract specific prey that it's like having a personalized neon sign in the darkness. Different species of bacteria produce different wavelengths, and the fish has learned to cultivate exactly the right microbial partners for its hunting strategy. Now imagine you could witness this underwater light show, the darkness around you suddenly alive with pinpricks of blue and green. Like stars scattered through liquid space, a jellyfish drifts past, its bell pulsing with waves of bioluminescence that ripple outward like cosmic fireworks. In the distance, a siphonophore stretches across your field of vision, a living string of lights that can extend for over 150 feet, making it longer than a blue whale and arguably one of the longest creatures on Earth. But bioluminescence isn't just beautiful, it's incredibly sophisticated. These creatures use light for communication in ways that put our most advanced technology to shame. They can produce flashes that last mere microseconds, or sustained glows that continue for hours. They can create patterns, sequences, and rhythms. Some species flash in synchrony, like underwater fireflies, creating massive displays visible for miles through the darkness. And here's something that will make you rethink everything you know about marine life. Scientists recently discovered that some deep-sea creatures don't just produce light, they vomit it. Certain species of deep-sea shrimp, when threatened, will expel luminous secretions from their mouths, creating a cloud of glowing confusion that allows them to escape, while predators are disoriented by the light show. It's like having a built-in smoke bomb, except instead of smoke, it's liquid starlight. The sophistication of these light-based communication systems becomes even more remarkable when you consider that many deep-sea creatures are essentially living in the most extreme sensory deprivation chamber on Earth. No sunlight has ever reached their world. No seasons mark the passage of time. Temperature barely fluctuates. In this realm of eternal sameness, bioluminescence becomes not just communication, but art, identity, and survival, all wrapped into one evolutionary masterpiece. But light isn't the only sense that's been transformed in the deep sea. Let's talk about something even more alien, the ability to sense electricity itself. Sharks and rays have specialized organs called the ampullae of Lorenzini, gel-filled canals scattered around their heads that can detect the faintest electrical fields generated by other living creatures. Imagine being able to sense the electrical signature of a heartbeat from across a room. In the deep sea, this bioelectrical sense is so refined that predators can hunt prey buried completely in sediment, invisible to every other sense but betrayed by the faint electrical activity of their own life processes. Some fish take this even further, actually generating their own electrical fields and sensing how objects in their environment distort those fields. It's like having biological radar, allowing them to navigate and hunt in complete darkness with precision that would make our most advanced sonar systems seem crude by comparison. They live in a world of electrical shadows and bioelectric echoes, perceiving their environment through the language of living electricity. Now let's venture into the truly alien realm of the abyssal plains. These vast underwater deserts cover more than 70% of our planet's surface, making them the largest habitat on Earth. They stretch for thousands upon thousands of kilometers across ocean basins, flatter than any surface on our continents. The sediment here accumulates so slowly that less than an inch builds up over 1,000 years. Some surfaces on these plains haven't been disturbed for millions of years, making them among the most stable environments on Earth. Yet even here, in this seemingly barren expanse, life finds a way. Scattered across the abyssal plains like alien artifacts are formations called polymetallic nodules. These potato-sized lumps of metal-rich minerals lie scattered across the seafloor. And here's the mind-blowing part. Scientists have recently discovered that these nodules might actually be producing oxygen in complete darkness. This discovery turns everything we thought we knew about oxygen production upside down. For billions of years, we believed that oxygen could only be created through photosynthesis, the process by which plants use sunlight to split water molecules and release oxygen as a byproduct. But somehow, these metallic nodules scattered across the deep sea floor are generating what scientists are calling dark oxygen, producing this life-giving gas without any help from the sun whatsoever. The implications of this discovery are staggering. If oxygen can be produced in the absence of sunlight, it opens up entirely new possibilities for life, not just in our own deep oceans, but potentially on other worlds throughout the universe. The same chemical processes that create dark oxygen in our abyssal plains might be operating in the subsurface oceans of Jupiter's moon, Europa, or Saturn's moon, Enceladus, worlds that have been locked in darkness for billions of years, yet might harbour thriving ecosystems we never imagined possible. But perhaps even more extraordinary than dark oxygen is what lives alongside it. The creatures of the abyssal plains have evolved strategies for survival that seem to defy the basic rules of biology. Take the xenophyophores we mentioned earlier, those single-celled giants that can grow larger than dinner plates. These mysterious organisms create intricate three-dimensional structures that serve as living apartment buildings for countless smaller creatures. They're ecosystem engineers, single cells that modify their environment on a scale that rivals what entire colonies of social insects accomplish. The fact that a single cell with no brain, no nervous system, no complex organs can create habitat for other species challenges our fundamental understanding of what it means to be alive. These creatures exist at the boundary between individual organism and ecosystem, between life and environment. They blur the lines we usually draw around biological categories, reminding us that nature is far more creative and flexible than our human concepts can easily contain. Living alongside these giants are creatures that seem to come from the pages of science fiction. There are sea cucumbers that look like translucent ghosts drifting across the seafloor. Their bodies so perfectly transparent you can see their internal organs pulsing with life. There are fish with antifreeze proteins in their blood, preventing ice crystals from forming in their tissues despite the near-freezing temperatures of the deep ocean. And then there are the scavengers, creatures that have turned the scarcity of food in the deep sea into an evolutionary advantage. When a whale dies at the surface and its carcass sinks to the abyssal depths, it creates what scientists call a whale fall, an oasis of nutrition in the food deserts of the deep sea. These whale falls can sustain entire communities of specialized creatures for decades, creating temporary ecosystems that bloom and fade like underwater gardens. The creatures that colonize whale falls arrive in waves, each adapted to feed on a different stage of decomposition. First come the mobile scavengers, hagfish and sleeper sharks, that strip away the soft tissues. Then come the bone-eating worms, bizarre creatures that actually dissolve whale bones from the inside out, extracting the lipids trapped within. Finally, come the bacteria that break down the last chemical remnants, creating a final bloom of microbial life that can persist for years after the whale itself has completely disappeared. This cycle of death and renewal in the deep sea reveals something profound about life itself. In a world where energy is scarce and every calorie is precious, nothing is wasted. Every death becomes the foundation for new life. Every ending becomes a beginning. The deep sea operates on principles of recycling and renewal that put our most advanced sustainability efforts to shame. But recent discoveries have revealed that life are only scratching the surface of the deep sea's mysteries extends far deeper than anyone imagined, not just down into the water column, but actually beneath the seafloor itself. Scientists have found thriving communities of tube worms, marine snails, and other creatures living in tiny cavities and cracks underneath the ocean floor, creating a hidden three-dimensional ecosystem that extends both above and below the boundary we thought separated life from lifeless rock. This subsurface world operates by its own rules. Cold seawater seeps down through cracks in the seafloor, mixing with warm, mineral-rich fluids rising from deep within the Earth's crust. This creates a complex network of chemical gradients and temperature zones, each supporting its own unique community of life. It's like discovering that the ocean has a basement, and that basement is teeming with creatures we never knew existed. The implications of this discovery are staggering. If life can thrive in the subsurface of our own ocean floor, what does that mean for the possibility of life in the subsurface oceans of other worlds? Mars might have liquid water flowing through underground networks of caves and fractures. The icy moons of the outer solar system almost certainly have vast oceans hidden beneath their frozen surfaces. If life can exist in the hidden spaces beneath our own seafloor, then these alien worlds suddenly seem much more promising as potential harbours for life. And here's where the story becomes even more remarkable. The genetic analysis of creatures from these hidden ecosystems reveals that they've evolved incredibly rapidly, adapting to extreme conditions in what amounts to evolutionary fast forward. Some species appear to have colonized the deepest ocean trenches and adapted to crushing pressures in just a few million years, a blink of an eye in geological terms. This rapid evolution suggests that life's ability to colonize extreme environments might be more dynamic and flexible than we ever imagined. When conditions are harsh enough, evolution doesn't just proceed gradually over millions of generations. It can apparently shift into overdrive, producing dramatic adaptations in remarkably short periods of time. The deep sea is teaching us that life is not just resilient, it's creative, it's opportunistic, it's endlessly inventive. Every impossible challenge becomes an evolutionary opportunity. Every extreme condition becomes a niche waiting to be filled. The crushing pressure that would destroy surface life becomes a protective barrier. The eternal darkness becomes a canvas for biological light shows. The toxic chemicals that would poison most creatures become the foundation for entirely new forms of metabolism. As we continue our journey deeper into the abyss, we'll discover how some creatures have learned to hunt with sound itself, using biological sonar more sophisticated than anything human technology has achieved. We'll explore the deepest trenches on Earth, places where the pressure is so intense that it creates entirely new states of matter. Yet life still finds a way to thrive. And we'll uncover the latest discoveries that suggest the deep sea might hold the key to understanding not just life on Earth, but the possibility of life throughout the universe. But the true masters of impossible survival aren't found on the abyssal plains or even in the hidden world beneath the seafloor. They live in places so extreme that they redefine what we mean by the word life itself. These are the extremophiles, the lovers of extreme conditions, and they inhabit environments that would make the surface of Mars seem hospitable by comparison. Imagine water so hot it should be steam, yet remains liquid under crushing pressure. Imagine temperatures that would melt copper, yet somehow support thriving communities of microorganisms. Around hydrothermal vents scattered across the ocean floor, scientists have discovered bacteria that not only survive in water heated to over 400 degrees Fahrenheit, they actually require these scorching temperatures to live. These heat-loving thermophils represent some of the most ancient forms of life on Earth, and they might hold the key to understanding how life first emerged from the primordial soup of early Earth's oceans. The chemistry of these thermophilic bacteria is so alien to our surface world that it reads like science fiction. Instead of using oxygen to power their metabolism, they breathe hydrogen gas and sulfur compounds. They live off chemicals that would poison most life forms, thriving in acidic conditions that would dissolve human flesh in seconds. Yet somehow, they've not only adapted to these hellish conditions, they've mastered them so completely that they cannot survive anywhere else. The discovery of these extreme microorganisms has revolutionized our understanding of life's possibilities. For decades, scientists used the DNA enzyme called Taq polymerase, first discovered in bacteria living in the hot springs of Yellowstone National Park. This enzyme's ability to function at high temperatures made it essential for genetic research and biotechnology. But the thermophils living around deep-sea hydrothermal vents have proven even more remarkable, producing enzymes that remain stable at temperatures that would destroy any protein we thought possible. What makes these discoveries so profound is what they tell us about the origins of life itself. The conditions around hydrothermal vents, with their cocktail of heat, pressure, and exotic chemistry, are remarkably similar to what early Earth might have been like billions of years ago. If life could emerge and thrive in these extreme conditions today, then perhaps the violent, chaotic early Earth wasn't the hostile environment we once imagined, but rather the perfect nursery for life's first tentative experiments. But even more extraordinary than the thermophils are the creatures that have learned to see in ways that transcend anything in our surface world. Deep beneath the waves, where no sunlight has penetrated for billions of years, evolution has crafted eyes that can detect single photons of bioluminescent light. These are optical systems so sensitive they make our most advanced night vision technology seem primitive by comparison. Consider the giant tube worms that cluster around hydrothermal vents, creatures that grow 8 feet long, yet have no mouth, no stomach, no digestive system whatsoever. How do they feed? They've entered into one of the most intimate partnerships in all of biology, housing colonies of chemosynthetic bacteria within their bodies. These bacterial partners feed on the chemical energy streaming from the vents, converting hydrogen sulfide and other toxic compounds into organic nutrients that sustain their giant hosts. It's a relationship so perfectly evolved that neither partner can survive without the other. These tube worms anchor themselves to the seafloor as adults and spend their entire lives in one spot, like underwater trees swaying in the chemical currents of their hydrothermal garden. Yet somehow, their larvae manage to disperse across vast distances of ocean, riding deep-sea currents to find new vents where they can establish their own colonies. How they navigate across thousands of miles of featureless abyssal plain to find these tiny oases of chemical energy remains one of the great mysteries of deep-sea biology. The partnerships between deep-sea creatures and their microbial companions reveal something profound about the nature of life itself. We tend to think of organisms as discrete, individual entities, but in the deep sea, the boundaries between self and other become beautifully blurred. Many deep-sea creatures are not just single organisms, but walking ecosystems, their bodies home to entire communities of bacteria, each playing a specialized role in keeping their host alive. This symbiotic way of life might actually represent the future of biology. As we face challenges like climate change and resource depletion, studying these deep-sea partnerships could teach us new ways of thinking about cooperation, sustainability, and survival. These creatures have solved problems of energy scarcity and waste management that we're still struggling with, using biological solutions that are elegant, efficient, and completely renewable. But perhaps the most mind-bending aspect of deep sea life is how it challenges our basic assumptions about consciousness and intelligence. We're used to thinking of intelligence as something that requires a brain, a nervous system, complex cognitive structures. Yet in the deep sea, single-celled organisms like the giant xenophiles somehow coordinate the construction of elaborate three-dimensional structures without any central controlling intelligence whatsoever. These mysterious creatures, some growing larger than dinner plates, create intricate architectural frameworks that serve as habitat for countless smaller organisms. They're ecosystem engineers, but they accomplish this engineering feat without anything resembling conscious thought or planning. It's as if the intelligence is distributed throughout their cellular structure, emerging from the complex interactions of countless molecular processes we're only beginning to understand. Recent research has revealed that these giant single cells might actually be using a form of biological computation, processing information about their environment through chemical networks that function like living computers. They respond to changes in water chemistry, temperature, and pressure with alterations to their growth patterns and structure. In a sense, they're constantly calculating the optimal way to build their living architecture, using algorithms written in the language of biochemistry rather than computer code. This distributed intelligence becomes even more remarkable when we consider the vast networks that connect deep-sea ecosystems. Scientists have discovered that the seafloor and the hidden cavities beneath it form an interconnected three-dimensional habitat where warm and cold waters mix, creating chemical gradients that support different communities of life at different depths and locations. It's like discovering that the ocean floor has its own internet, a network of chemical communication that allows organisms separated by vast distances to coordinate their activities. The implications of this hidden connectivity are staggering. When we think about protecting deep-sea ecosystems, we usually focus on the visible communities on the seafloor surface. But if these surface communities are connected to vast underground networks of life, then protecting them means protecting entire regions of the deep sea, including areas we can't even see or map. This challenge becomes even more urgent when we consider the growing threat of deep-sea mining. The same polymetallic nodules that might be producing dark oxygen are also rich in rare earth metals, essential for renewable energy technologies. The irony is profound. In our effort to develop clean energy solutions for the surface world, we might destroy ecosystems in the deep sea that we're only beginning to understand. The race between discovery and exploitation has never been more critical. Every month brings new revelations about the complexity and interconnectedness of deep sea life, but every month also brings us closer to large-scale industrial activities that could disrupt these ancient ecosystems before we fully understand what we're potentially losing. Some of the most recent discoveries suggest that deep-sea ecosystems might play a crucial role in regulating Earth's climate over geological timescales. The abyssal plains function as massive carbon sinks, storing carbon dioxide removed from the atmosphere and locking it away in deep sea sediments for millions of years. The slow circulation of deep ocean waters helps distribute heat around the globe, moderating temperature extremes and stabilizing weather patterns. If industrial activities disrupt these processes, the consequences could ripple through Earth's entire climate system in ways we can't predict or control. We might be on the verge of disturbing regulatory mechanisms that have kept our planet's climate stable for millions of years, all in pursuit of resources we've barely begun to understand. But even as we face these challenges, the deep sea continues to reveal wonders that inspire hope and amazement. Scientists recently discovered that some deep sea creatures can actually manipulate time itself, or at least their perception of it. In the extreme cold and high pressure of the deep ocean, metabolic processes slow down so dramatically that some organisms experience time at a completely different rate than surface life. There are deep sea clams that can live for over 500 years, growing so slowly that decades pass between growth rings in their shells. There are tube worms at hydrothermal vents that might live for centuries, their bacterial partners passing through countless generations while their hosts remain essentially unchanged. These creatures exist in a biological slow lane, where evolution proceeds at a pace that makes our human timescales seem frantic and rushed. This temporal perspective offers a profound lesson about patience and persistence. In a world obsessed with speed and instant results, the deep sea reminds us that some of the most important processes in life unfold over vast stretches of time. The gradual accumulation of sediments, the slow circulation of deep waters, the patient construction of living architecture by giant single cells. All these processes contribute to the stability and resilience of our planet's life support systems. As we continue our exploration of the deep sea's secrets, we'll discover creatures that hunt with weapons made of pure sound, organisms that can survive being completely frozen and then thawed back to life, and ecosystems so alien they're helping scientists prepare for the possibility of life on other worlds. We'll explore the deepest trenches on Earth, where pressure creates conditions so extreme they might represent entirely different states of matter. Yet life somehow persists even there. The deep sea is more than just Earth's final frontier. It's a laboratory for understanding life's ultimate possibilities. Every creature we discover, every ecosystem we map, every impossible adaptation we document expands our conception of what life can achieve when faced with seemingly insurmountable challenges. In this realm of perpetual night, where crushing pressure meets scorching heat and toxic chemicals become the foundation of thriving ecosystems, we find not just alien life, but alien wisdom. The deep sea teaches us that there are always solutions we haven't imagined, partnerships we haven't considered, ways of being alive that transcend our limited surface perspective. The creatures of the deep sea don't just survive in impossible conditions, they transform those conditions into opportunities. They turn scarcity into abundance, isolation into community, darkness into light. They remind us that life is not just resilient, it's endlessly creative, finding ways to flourish in places and circumstances that seem to prohibit life entirely. As we drift deeper into this exploration, let yourself imagine floating through these alien realms, surrounded by living light and impossible creatures, witnessing firsthand the creativity and resilience that life displays when freed from the constraints of our familiar surface world. The deep sea is calling to us, whispering secrets about survival, adaptation, and the infinite possibilities that emerge when life embraces the impossible rather than merely enduring it. As we venture into the deepest trenches on our planet, we encounter something that seems to defy the very laws of physics. Here, 7 miles beneath the surface, the pressure becomes so intense that water itself begins to behave in ways that challenge our understanding of matter. At these crushing depths, water molecules pack together so tightly they approach the density of solid rock, yet somehow remain fluid. It's a state of matter that exists nowhere else on Earth's surface. A liquid that's almost solid, flowing like honey made of compressed starlight. In these deepest places, life faces pressures equivalent to having the entire weight of the atmosphere pressing down on every square inch of surface, not once but over 1,000 times. Yet even here, in conditions that would instantly obliterate any surface creature, we find the hadal snailfish swimming gracefully through liquid that's denser than anything we experience in our surface world. These remarkable fish represent one of evolution's most recent and rapid adaptations. Genetic analysis suggests they colonized these extreme depths and fully adapted to crushing pressures in just a few million years, an evolutionary sprint that rewrote the rules of vertebrate biology. Their bodies are living laboratories of adaptation, producing massive quantities of specialized molecules that protect their proteins from collapsing under pressure. But perhaps most remarkably, these fish seem to thrive in their crushing world. They don't just survive the pressure, they require it. When brought to lower pressures, their bodies literally expand and fall apart. Their cellular machinery so perfectly tuned to extreme conditions that they cannot exist anywhere else. They've become prisoners of their own perfection, locked into the deepest places on Earth by the very adaptations that allow them to live there. Now imagine descending even deeper, past the realm of the snailfish, into trenches so deep they create their own weather systems. At the bottom of these oceanic canyons, underwater rivers of dense cold water flow like liquid mercury across the seafloor. These deep-sea rivers can stretch for hundreds of miles, carrying sediments and nutrients through valleys that dwarf the Grand Canyon, yet remain completely invisible from the surface. In these deepest reaches, we encounter creatures that seem to exist at the very edge of what's physically possible. There are amphipods, tiny shrimp-like creatures that have been found at depths where the pressure should theoretically prevent any complex life from existing. Yet somehow, they found ways to compress their cellular machinery into forms so efficient, so perfectly optimized, that they can maintain the delicate chemistry of life, even under these crushing conditions. These deepest ecosystems operate on principles that seem almost mystical. Food is so scarce that a single organic particle drifting down from the surface might support an entire community for months. Every calorie is precious, every molecule of nutrition is recycled through countless organisms before finally being incorporated into the sediment. It's biological economics pushed to its absolute limit, where waste is not just inefficient but literally impossible to survive. But here's where the story takes a turn toward the truly extraordinary. Scientists have discovered that some deep-sea creatures don't just adapt to extreme conditions, they actively create them. Certain species of bacteria living in the deepest trenches actually generate their own high-pressure environments, using specialized cellular pumps to create pressure differentials that help them extract energy from their surroundings. It's like discovering that some organisms have learned to be their own weather systems, creating the exact conditions they need to thrive, regardless of what's happening in the environment around them. These pressure-generating bacteria might represent the ultimate expression of biological independence, life forms that have become so self-sufficient they can literally create their own world wherever they happen to find themselves. The implications of this discovery extend far beyond Earth's oceans. If life can not only adapt to extreme conditions, but actually generate those conditions for itself, then the possibilities for life throughout the universe expand dramatically. The subsurface oceans of Europa and Enceladus, the underground rivers of Mars, the high-pressure atmospheres of gas giant moons, all suddenly become potential harbours for life forms that might be creating their own perfect environmental bubbles in the most unlikely places. This brings us to one of the most profound questions the deep sea raises about the nature of life itself. We tend to think of organisms as being shaped by their environment, moulded by natural selection to fit into ecological niches. But what if the relationship is more complex than that? What if life doesn't just adapt to environments, but actively participates in creating them? The deep sea suggests that the boundary between organism and environment might be far more fluid than we imagine. The giant xenophophores that build living architecture, the bacteria that generate their own pressure systems, the tube worms that cultivate their own food sources. All of these creatures blur the line between adaptation and creation, between responding to the world and actively shaping it. This perspective transforms how we think about life's relationship with seemingly hostile environments. Perhaps the deep sea isn't hostile at all, but simply different. Perhaps what we perceive as extreme conditions are just alternative ways of organizing matter and energy, different solutions to the fundamental challenges of existence. The crushing pressure, the eternal darkness, the toxic chemistry, all of these might not be obstacles to life, but simply different starting points for life's endless creativity. Consider the recent discovery of deep-sea creatures that can manipulate sound itself as a tool for survival. In the darkness of the abyss, where vision is useless and chemical signals travel slowly, some organisms have evolved biological sonar systems more sophisticated than anything human technology has achieved. They generate clicks, whistles, and complex acoustic patterns that paint detailed pictures of their surroundings using sound waves alone. But these aren't just simple echolocation systems like those used by dolphins or bats. Some deep-sea creatures have learned to use sound as a weapon, generating acoustic bursts so intense they can stun or disorient prey from a distance. Others use subtle acoustic camouflage, producing sounds that mask their presence from predators by mimicking the background noise of the deep ocean environment. The acoustic landscape of the deep sea turns out to be incredibly rich and complex. A three-dimensional soundscape where creatures communicate, hunt, and navigate using frequencies and patterns we're only beginning to understand. Some deep-sea sounds travel for thousands of miles through the ocean, creating communication networks that span entire ocean basins. Whales use these deep sound channels to communicate across continents, but they're not alone. The deep sea itself is full of mysterious sounds, clicks and pulses and haunting melodies whose sources remain unknown. This hidden acoustic world reveals something profound about consciousness and intelligence in the deep sea. If creatures are using sound to create detailed maps of their environment, to communicate complex information, to coordinate group behaviours across vast distances, then what does that tell us about the nature of awareness in these alien realms? Are we witnessing forms of intelligence so different from our own that we barely recognize them as intelligence at all. The question becomes even more intriguing when we consider the recent discoveries about deep-sea creatures that seem to exist in a state of suspended animation. In the extreme cold and high pressure of the deepest waters, some organisms can slow their metabolism to almost nothing, entering a state where biological time nearly stops. They become living fossils, their bodies preserving information about ocean conditions from decades or even centuries in the past. These time-dilated creatures offer us a window into the deep sea's history, living libraries of environmental data that stretch back through geological ages. By studying their tissues, their growth patterns, their chemical composition, scientists can reconstruct changes in ocean temperature, chemistry, and circulation that occurred long before human civilization began keeping records. But perhaps even more remarkable is what these discoveries suggest about the nature of time itself in the deep sea. If creatures can exist in states where minutes become hours, hours become days, days become years, then what does that mean for their experience of existence? Do they perceive the world at a different temporal resolution than surface life? Are they living in slow motion, watching the ocean change at a pace that makes our human timescales seem frantic and rushed? This temporal perspective offers profound insights into the nature of patience and persistence. In our surface world of constant change and rapid adaptation, we sometimes forget that the most important processes often unfold over vast stretches of time. The formation of mountains, the evolution of species, the circulation of deep ocean waters, all of these fundamental processes operate on timescales that dwarf human experience. The deep-sea creatures that exist in biological slow motion might be the ultimate practitioners of long-term thinking. They make decisions and execute strategies that unfold over decades or centuries. They've learned to thrive in a world where success is measured not in moments or years, but in geological ages. They remind us that sustainability isn't just about managing resources efficiently. It's about thinking and planning on timescales that extend far beyond our individual lifespans. This brings us to one of the most important lessons the deep sea offers for our surface world. As we face challenges like climate change that require thinking on geological timescales, perhaps we need to learn from these masters of deep time. Their patience, their persistence, their ability to maintain stability in the face of slow but profound changes, all of these qualities might be essential for navigating the long-term challenges facing our planet. The deep sea also teaches us about resilience in ways that transcend individual survival. When hydrothermal vents shut down due to geological changes, entire ecosystems must relocate or perish. Yet somehow, life finds a way to disperse across vast distances of hostile ocean to colonize new vents as they form. These migrations happen over timescales and distances that boggle the imagination, yet they happen with such regularity that scientists now recognize them as fundamental features of deep-sea ecology. The mechanisms that allow this dispersal remain largely mysterious. How do microscopic larvae navigate across thousands of miles of featureless abyssal plain to find new hydrothermal vents? How do they survive journeys that might take months or years through waters that offer no food, no shelter, no landmarks? Some scientists speculate that deep-sea creatures might use magnetic fields, chemical gradients, or acoustic signals as navigation aids, but the truth is we still don't understand how life accomplishes these seemingly impossible journeys. What we do know is that these migration patterns reveal something profound about the interconnectedness of deep-sea ecosystems. What appears to be isolated oases of life scattered across the abyssal plains are ecological interaction that span entire ocean basins. They're actually connected by invisible threads of biology, networks of genetic exchange, and deep sea isn't a collection of separate ecosystems, but a single, integrated planetary system where changes in one location can ripple across thousands of miles of ocean. This global connectivity becomes especially important as we consider the future of deep-sea exploration and exploitation. The mining of polymetallic nodules, the harvesting of rare earth metals, the installation of deep-sea cables and infrastructure. All of these activities could disrupt migration routes and ecological connections that have existed for millions of years. We might inadvertently sever biological networks that are essential for maintaining the diversity and resilience of deep-sea life. The race between discovery and development has never been more critical. Every expedition to the deep sea reveals new species, new ecosystems, new forms of biological organization that challenge our understanding of life's possibilities. Yet every year brings us closer to large-scale industrial activities that could alter these ancient systems in ways we can't predict or reverse. Perhaps most importantly, the deep sea reminds us that our planet is still full of mysteries, still capable of surprising us, still home to wonders we've never imagined. In an age when we sometimes feel like we've mapped and catalogued everything on Earth, the deep sea stands as proof that we've barely begun to explore our own world. Less than 5% of the ocean has been directly observed by humans. Less than 20% has been mapped even with sonar. The vast majority of our planet's surface remains as unknown today as it was to our ancestors thousands of years ago. This unknown world beneath the waves offers us something precious in our modern age, the gift of genuine mystery. In the deep sea, we can still experience the wonder of discovery, the excitement of encountering something truly alien, the humbling reminder that life is far more creative and resilient than our limited imagination suggests. Every dive into the abyss brings back creatures that seem impossible, ecosystems that operate by unknown rules, forms of life that expand our understanding of what it means to be alive. And so here we are at the end of our gentle descent into Earth's most alien realm. We've discovered that the greatest frontier for exploration isn't among distant stars, but right here beneath the waves in our own backyard. The deep sea has shown us creatures that breathe poison, create living light, and thrive in pressures that would crush submarines, reminding us that life is not just resilient but endlessly creative, transforming impossible conditions into evolutionary opportunities. As you drift towards sleep tonight, let your thoughts carry the wonder of these hidden worlds, where bioluminescent gardens bloom in eternal darkness and where the very chemistry of existence operates by rules we're only beginning to understand. Before we part, I'd love to know where in the world you're listening from tonight and what time it shows on your clock, whether it's the quiet hours in Tokyo or a peaceful evening in London. I'm always amazed by how far these gentle explorations travel. If this journey into the deep sea sparked your curiosity, consider giving it a gentle like and subscribing to join our community of fellow wanderers. And if you're ready for our next voyage together, we'll be exploring something even more mind-bending. Can we comprehend the mind-bending size of the universe? Until then, may your dreams be filled with living light in eternal darkness, and may you always remember that the most extraordinary discoveries often lie closest to home. Sleep well and good night. Well and good night.